You ever touched something hot and instantly pulled your hand away even before you realized what happened? It's your body's reflex mechanism in action. Reflexes are automatic, rapid responses to certain stimuli designed to protect us from harm. In this video, we'll explore how reflexes work, why they're so fast, and what makes them different from regular voluntary actions. Let's start by understanding what a reflex is and why it's essential for our survival. Reflex mechanism is an involuntary and nearly instantaneous movement in response to a stimulus. Unlike actions we consciously control, reflexes happen without us thinking about them. This automatic process is crucial for protecting our bodies from danger and maintaining basic bodily functions. For example, blinking when something approaches your eyes or sneezing when dust enters your nose are both reflexes. These actions are hardwired into our nervous system, ensuring quick responses to keep us safe. Nervous system is the command center for reflexes. It consists of the brain, spinal cord, and a network of nerves throughout the body. When a stimulus is detected, sensory nerves carry the information to the spinal cord. The spinal cord then processes the signal and sends instructions back to the muscles, triggering a quick response. This pathway allows reflexes to happen much faster than if the brain were involved in every step. The nervous system's efficiency is what makes reflexes so rapid and reliable. Every reflex begins with a stimulus, something that triggers a reaction. This could be touching a hot surface, a sudden loud noise, or a bright light. The body's sensory receptors detect the stimulus and immediately send a message through the nerve to the spinal cord. The spinal cord acts as a relay station, quickly deciding on the appropriate response and sending signals to the muscles to act. This entire process happens in a fraction of a second, ensuring our safety. Reflexes can be classified in two main types, simple and complex. Simple reflexes like the knee-jerk reaction involve only a few neurons and are very fast. Complex reflexes, such as withdrawing your hand from a hot object, may involve several muscles and more complicated nerve pathways. Both types are essential for daily life, helping us react to our environment and avoid harm. Understanding these types helps us appreciate the variety and importance of reflex action. Reflex arc is the pathway that a reflex signal follows. It starts with a sensory receptor detecting a stimulus. The signal travels along a sensory neuron to the spinal cord, where it connects with a motor neuron. The motor neuron then carries the signal to a muscle, causing it to contract. This direct route allows for a rapid response, bypassing the brain for speed. The reflex arc is a fundamental concept in understanding how reflexes work so efficiently. Sensory neurons are the messengers that carry information from the body's sensory receptors to the spinal cord. When you touch something sharp or hot, these neurons quickly transmit the signal, alerting the nervous system to potential danger. Their speed and efficiency are vital for the reflex mechanism, ensuring that the body can react before injury occurs. Without sensory neurons, our bodies wouldn't be able to detect or respond to harmful stimuli as quickly. Neurons are found within the spinal cord and act as connectors between sensory and motor neurons. When a sensory neuron brings in a signal, the interneuron processes the information and decides how to respond. This step is crucial for more complex reflexes, allowing the body to coordinate multiple muscles or adjust the strength of the response. Interneurons add flexibility and control to the reflex mechanism, making our reactions more precise. Motor neurons are the final link in the reflex arc. After receiving instructions from the spinal cord, they carry the signal to the muscles, causing them to contract or relax. This action produces the visible response, such as pulling your hand away from something hot. Motor neurons are essential for turning nerve signals into movement, completing the reflex process. Their quick response time is what makes reflexes so effective at protecting us. One of the most well-known reflexes is the knee-jerk reaction, often tested by doctors. When the patellar tendon below your kneecap is tapped, sensory neurons send a signal to the spinal cord. The spinal cord immediately sends a message back through motor neurons, causing your leg to kick out. This simple reflex helps doctors check the health of your nervous system and ensures your muscles are working properly. Withdrawal reflex is another common example. If you touch something painful like a hot stove, your hand pulls away instantly. This reflex involves sensory neurons detecting pain, interneurons processing the signal, and motor neurons activating the muscles. The entire process happens so quickly that you react before you even feel the pain fully. This reflex is crucial for preventing injury and keeping us safe in everyday life. Blink reflex protects our eyes from danger. When something approaches your face quickly, your eyelids close automatically. This reflex is triggered by sensory receptors around the eyes, which send signals to the brainstem and then to the muscles controlling the eyelids. The blink reflex is essential for keeping our eyes safe from dust, debris, or sudden threats, and it happens in just milliseconds. Sneezing is a reflex that helps clear irritants from our nasal passages. When dust or pollen enters the nose, sensory receptors detect the particles and send signals to the brainstem. The brainstem then triggers a powerful, coordinated muscle contraction, causing a sneeze. This reflex is vital for protecting our respiratory system and keeping our airways clear of harmful substances. Cough reflex is another protective mechanism. When something irritates your throat or airways, sensory nerves send a signal to the brainstem. The brainstem then activates the muscles needed to produce a strong cough, expelling the irritant. This reflex helps prevent choking and keeps the lungs free of harmful particles. It's a vital part of our body's defense system. Pupil reflex controls the size of our pupils in response to light. When you step into bright sunlight, your pupils constrict to reduce the amount of light entering your eyes. This reflex protects the sensitive tissues inside the eye and helps you see clearly in different lighting conditions. The process is automatic and adjusts constantly as lighting changes around you. Babinski reflex is seen in infants when the sole of the foot is stroked. The big toe moves upward and the other toes fan out. This reflex is normal in babies but disappears as the nervous system matures. In adults, the presence of this reflex can indicate neurological problems. The Babinski Reflex is an important tool for doctors to assess nervous system development. Gag reflex prevents choking by causing the throat muscles to contract when something touches the back of the throat. This reflex is triggered by sensory nerves and helps protect the airway from foreign objects. It's especially important during eating and swallowing, ensuring that food goes down the right way and doesn't block the airway. Rooting reflex helps newborns find food. When you touch a baby's cheek, they turn their head and open their mouth ready to feed. This reflex is essential for survival in the early stages of life, guiding infants to their mother's breast or a bottle. The rooting reflex fades as babies grow and learn to feed voluntarily. Reflexes differ from voluntary actions in that they happen automatically, without conscious thought. Voluntary actions like picking up a cup involve the brain making a decision and sending signals to the muscles. Reflexes, on the other hand, are much faster because they bypass the brain and use the spinal cord for immediate response. This distinction is key to understanding how our bodies prioritize speed and safety. Reflexes are incredibly fast because they use a direct pathway through the spinal cord, avoiding the need for the brain to process the information first. This shortcut allows the body to react in milliseconds, which can be the difference between safety and injury. The speed of reflexes is a result of evolution, ensuring that we can respond to danger as quickly as possible. Any reflexes serve a protective function, shielding us from harm. Examples include pulling your hand away from something sharp, blinking to protect your eyes, and coughing to clear your airways. These reflexes are built into our nervous system and operate automatically, often before we're even aware of the danger. Their main purpose is to keep us safe in a constantly changing environment. Some reflexes help maintain the body's internal balance or homeostasis. For example, the baroreceptor reflex regulates blood pressure, and the pupillary reflex controls the amount of light entering the eye. These reflexes work behind the scenes to keep our bodies functioning smoothly, adjusting automatically to changes in our environment and internal state. Doctors often test reflexes to assess the health of the nervous system. By tapping tendons or checking responses to stimuli, they can detect problems with nerves or the spinal cord. Abnormal reflexes may indicate neurological disorders or injuries. Reflex testing is a simple yet powerful tool for diagnosing a wide range of medical conditions. Reflex mechanisms aren't unique to humans, animals rely on them too. For example, a cat's quick leap away from danger or a dog's scratch when it feels a tickle are both reflexes. These automatic responses help animals survive in the wild, escape predators, and adapt to their environment. Studying animal reflexes gives us insight into how these mechanisms evolved across species. Reflexes have evolved over millions of years to help living beings survive. The fastest and most effective reflexes were passed down through generations, becoming hardwired into the nervous system. This evolutionary process explains why reflexes are so reliable and why they exist in so many different species. Reflexes are a testament to the power of natural selection. While most reflexes are innate, some can be modified through learning and experience. For example, athletes train their bodies to react faster to certain stimuli, improving their reflexes over time. This ability to adapt shows that the nervous system is flexible and can fine-tune reflexes based on practice and repetition. Learning can enhance our natural reflexes, making us more responsive. Conditioned reflexes are learned responses that develop through experience. The most famous example is Pavlov's dogs, which learned to salivate at the sound of a bell after repeated pairings with food. Unlike innate reflexes, conditioned reflexes require training and repetition. They show how the brain can create new pathways and adapt to different situations. Athletes rely on quick reflexes to perform at their best. Whether it's a tennis player returning a fast serve or a soccer goalie diving for a save, reflexes are crucial for success. Training and practice help athletes sharpen their reflexes, allowing them to react faster and more accurately during competition. Reflexes can make the difference between winning and losing in sports. Driving safely depends on quick reflexes. When a car suddenly stops in front of you, your reflexes help you hit the brakes before your brain fully processes the danger. Good reflexes are essential for avoiding accidents and responding to unexpected situations on the road. Regular practice and alertness can help keep your reflexes sharp while driving. As we age, our reflexes tend to slow down. This is due to changes in the nervous system, such as slower nerve conduction and reduced muscle strength. Slower reflexes can affect balance, coordination, and reaction time, making older adults more vulnerable to falls and injuries. Staying active and healthy can help maintain reflex speed as we get older. Certain medical conditions can affect reflexes. For example, nerve damage, spinal cord injuries, or neurological diseases may weaken or exaggerate reflex responses. Doctors use reflex tests to help diagnose these disorders and monitor their progression. Understanding reflex disorders is important for managing symptoms and improving quality of life. Injuries to the spinal cord can disrupt reflex pathways, leading to loss or abnormal reflexes. Depending on the location and severity of the injury, some reflexes may be lost while others become exaggerated. Rehabilitation and therapy can help restore some function, but spinal cord injuries often have lasting effects on reflexes and movement. Diseases like multiple sclerosis, Parkinson's, or ALS can affect the nervous system and alter reflexes. These conditions may cause reflexes to become slower, weaker, or even disappear. Monitoring reflex changes helps doctors track disease progression and adjust treatment plans. early detection of abnormal reflexes can lead to better outcomes for patients. In emergencies, reflexes can save lives. For example, jumping out of the way of a moving car or catching yourself during a fall are reflex actions that happen without conscious thought. These rapid responses are essential for survival, allowing us to react instantly to danger. Training and preparedness can help improve reflexes in high-stress situations. Technology is being used to study and enhance reflexes. Virtual reality, motion sensors, and wearable devices can measure reaction times and help people train their reflexes. These tools are valuable in sports, rehabilitation, and even gaming, offering new ways to understand and improve our natural responses. Scientists are developing robots with reflex-like mechanisms to make them more responsive and adaptable. By mimicking human reflexes, robots can react quickly to changes in their environment, avoid obstacles, and perform tasks more efficiently. This technology is inspired by the natural reflexes found in humans and animals, showing how biology can influence innovation. Reflexes play a role in many daily activities, from catching a falling object to adjusting your posture when you slip. These automatic responses help us navigate the world safely and efficiently. We often take reflexes for granted, but they are constantly at work, protecting us and making life easier. You can improve your reflexes through practice and training. Activities like playing sports, video games, or even certain exercises can help sharpen your reaction times. Staying healthy, getting enough sleep, and managing stress also contribute to better reflex performance. With dedication, anyone can enhance their reflexes and become more responsive. Mental health can influence reflexes. Stress, anxiety, or fatigue may slow down reaction times, while relaxation and focus can enhance them. Taking care of your mental well-being is just as important as physical training when it comes to maintaining quick and effective reflexes. Children often have very sharp reflexes which help them learn and adapt quickly. Reflexes like grasping, sucking, and stepping are present from birth and play a key role in development. As children grow, these reflexes evolve and become more refined, supporting learning and coordination. Sleep is essential for maintaining healthy reflexes. During deep sleep, the nervous system repairs and strengthens the pathways involved in reflex actions. Lack of sleep can slow down reaction times and make reflexes less reliable. Prioritizing good sleep habits is important for keeping your reflexes sharp. Proper nutrition supports the nervous system and helps maintain fast reflexes. Nutrients like vitamins B and D, omega-3 fatty acids, and minerals are important for nerve health. Eating a balanced diet can improve your body's ability to respond quickly to stimuli and keep your reflexes functioning at their best. Research into reflex mechanisms continues to advance. Scientists are exploring new ways to measure, enhance, and even repair reflexes using technology, medicine, and training. The future may bring breakthroughs that help people recover lost reflexes or develop new ways to protect themselves from harm. Sum up, reflex mechanisms are automatic, rapid responses that protect us and help us adapt to our environment. They involve a complex network of neurons, including sensory, interneurons, and motor neurons, all working together to ensure our safety. Reflexes can be innate or learned, and they play a crucial role in everyday life, health, and survival. Reflexes are a fascinating part of the human body, blending biology, evolution, and daily experience. Whether it's a simple knee jerk or a complex learned response, reflexes keep us safe and help us interact with the world. By understanding how they work, we can appreciate the incredible efficiency of our nervous system and the importance of keeping it healthy.